hi everybody, and thanks for coming. Today I'd like to tell you something about Docker in context of developing Ruby on Rails application and sending it to continuous integration service and deploying it to the server. So my name is Adam, and I work as Ruby and JavaScript developer in Monterey. You can follow me on Twitter if you want, but no pressure. So before we begin Docker, let me tell you a kind of DevOps-ish developer story. So what got me to this point and what got me interested in Docker in the first place. And let's note here that I'm not really a DevOps engineer. I'm a developer who probably isn't as comfortable on the server as he should be. And from my experience, it can be said about many developers. So it's a DevOps story from developers' point of view. And it's a story about my side project. I wrote an app. And, as any decent developer should, at least from time to time. And what now? Well, I know I want people to use it, and I know I have to deploy it. And I know better than to just copy my code and start a development server. So this is a joke. Please don't do it. And, well, what does everybody do when they have a Rails app? Of course, Heroku. There is just one problem I had with Heroku. Remember, it's a side project. So it's $7 for the server and $9 for Postgres database over 10,000 rows. And I knew I would have over 10,000 rows because of my application's design. So this is a state after a couple of weeks, and it's over 200 records per person. So I knew that Heroku wouldn't be cheap for me in the long run. So, I did a quick math and decided to go the VPS route. And, don't get me wrong about Heroku, because Heroku is really awesome. And for what it offers you for, a couple dozens of dollars, it's really great. And if you are planning to have a revenue and don't want to spend your money on DevOps, Heroku is probably the way to go. But, when I thought about all the side projects that I wanted to do, I just didn't, it wasn't calculating for me. Especially that I wasn't ever planning to, make money on my application. So for $5 a month, I got a decent VPS, of course, DigitalOcean, and which is cool because I could do everything I wanted there, which is also a problem because I not only could do everything I wanted, I pretty much had to do everything. And what is the normal next step in this case? Well, how to deploy a Rails application. There are thousands of tutorials, and I won't get into it. You generally just find one tutorial, and you SSH to the server, go step by step, and do everything. So I just say that I chose Passenger as an application server, Nginx as an HTTP server, and Capistrano, of course. And, with this SSHing to the server, going through all the steps, and just deploying application in this way, well, it worked. But I had this big problem that kept bothering me, which is the repeatability of the server environment. And I asked myself the questions, what if I ever had to do this again? So what if what if the server crashed on users when they were most likely to use it? Would I have to stop my work and fix this side project or whatever? What if I ever wanted to, somehow scale and create a staging environment? And what if I just wanted to deploy a new Rails application? Would I have to, a month later, find the same tutorial and go through all the steps again? Well, I always saw DevOps work as working under big pressure. And it's really no wonder when it looks like this. But does it have to look like it? This is a buzzword you probably heard a lot, but it kind of struck with me because I test my code because I want things to be predictable and repeatable. I just sleep better. So the previous approach was nothing like my code. It was really, like hacking on the server and praying that it would never break. So I knew I had to automate the server setup part. And this is what infrastructure as code is really about. These are two tools that really help me with it. So Vagrant and Ansible. What is Vagrant? On their website, they say that it's development environments made easy. And I don't really buy it. I think Docker is better suited for the tool. But Vagrant is really helpful for me to kind of to set up a VPS on your local machine. So you set up Vagrant, and you pretty much can have local staging just on your computer. You don't have to pay for it. It's much faster because you connect to your local host instead of some server. And how do you work with Vagrant? So finally, I can show you some code. Unfortunately, there's not a lot of it. But fortunately, this is because setting up Vagrant is this simple. This is literally my only Vagrant configuration I ever needed. And the most important line is here, where you specify a box, so in this case, a distribution you want to use. And we just say that we want to use Ubuntu Server 1404, and this is it. Then, when you have this one file, you can run Vagrant app. You SSH to your server, you break everything there is to break. Then you go back to your host machine, you run Vagrant destroy, Vagrant app, and you're good as new. After 5 seconds, you can have just new VPS just for your own. So this was cool for me, and this is the environment where I tested the Ansible on. So Ansible is an automation tool which is configured using pretty readable YAML files. And, well, why did I choose Ansible? Because of its simplicity. There are other tools for the job, for example, Chef or Salt or Puppet, but I found Ansible to be the simplest. And all you really need is an SSH access to your server and no client on the server, whatever. So it was the simplest for me. And this is how I provisioned my server. So first, we specify our hosts, which are just IPs of our servers. Then we specify a remote user, which will run all the commands. And then we have some pretty generic roles and our site-specific roles. And in the generic ones, we install some Linux prerequisites. I don't even really know what it does. We install Postgres, we install Ruby with RBN, and we install Nginx. So these are pretty generic, and you can either write your own or download them from Ansible's repository, which is called Ansible Galaxy. And we have some site-specific roles. In my case, it was prepare site and copy env. Copy env is pretty straightforward, and prepare site really does only 3 things. It creates our database for our application, it copies our database YAML to the shared folder, and it copies nginx config. And after this, we just run capistrano deploy, and our code works, so our application works. So getting to this part was very exciting for me. And I knew that I could configure server and deploy my application in like 5 minutes, while actually just watching the logs and drinking coffee in this time. But I thought, well, again, can we do better than this? It still felt kind of complex for me, just having all this in mind and keeping these YAML files, etc. Well, I heard about Docker a couple of times before, maybe 1, twice, or 200 times. It's kind of like buzzword in itself. So, well, maybe this approach could help me. So what is Docker? I won't give you any definition because I don't really know it. But my understanding of Docker is that Docker is your application in a container, which is cool. But what does it mean? What is a container? So when you Dockerize your application, you get your whole application, you take all your dependencies. So in the example of Rails application, you run bundle install, so you download all the gems. And for the production image, you want to precompile your assets. So most likely, these are your dependencies. And you take all of this, and you put it behind a common interface. And this is what I understand by common interface. So this is what I mean by common interface. You can run your Ruby or PHP or Python applications without knowing neither Ruby or PHP or Python. So imagine you have an application and you don't really care what is it written with. What's the technology behind it? Your host machine don't need to understand any of this technology. All it needs to understand is Docker, and then it just works. And how is it different from virtual machine? This is an image that I took from Docker docs, and I really encourage you to go to Docker website and look at their docs because they really were written. And in virtual machine, the biggest difference is that you ship virtual machine with the whole guest operating system. So not only your computer or your server must run an operating system, but all the virtual machines must also run the whole system. So, for example, whole Debian or Ubuntu server or whatever. And Docker, in contrast, doesn't need this overhead. The biggest part of operating system, which is kernel in this case, is shared with the host operating system. So this is shared with Docker, and Docker still can run, for example, Debian or Ubuntu, but it doesn't need to ship with whole kernel. So instead of shipping, I don't know, 50 megabytes application with virtual machine as, I don't know, 700 megabytes virtual machine, you can ship it with, for example, 100 or 200 megabytes Docker image. And this is really the only file that you need to configure Docker with Rails application. And it is literally only file. So Docker takes this file, it builds an image based on it, and then you can run it. So what does it do? First, we specify our base image, which in this case is Ruby image version 2.2. And this is the only requirement in Docker file. All other commands are optional. And so you can think of it as kind of inheritance in Docker world. So you inherit from the Ruby image inherits from Debian image, and unfortunately I don't know what's on the other part of the rainbow. But if you know, please let me know. And so you have this Ruby, and then we can run some commands. So we can run apt get install node.js because Ruby is based on Debian, which gives us the apt command. And Ruby itself installs Ruby, so we can install gem install bundler. Then we create our app directory, copy our gem files, and run bundle install. Then we copy our whole application to the image. So we just shamelessly take all the files and we copy it to the image. Fortunately, as a side note, we don't have to copy everything. There is a file called docker ignore, which works just like git ignore, and we can exclude, for example, git directory or public directory, etc., which our application don't need to be shipped with. And after we copy it, we specify a default run command. So in this case, it's our development Rails server. And this is what we do with it. We just run docker build, we tag it with my project name and a directory. And Docker builds our image, and then we have access to docker run command. We can expose a port to our host computer, and we specify the tag we build the image with. And this is literally everything to start a Rails application. And the bad news is our application still won't work because we don't have a database. So we could install a Postgres database on our local machine and connect to it with, for example, IP. But the better way is to run for Postgres, in my case, as a Docker container. So to start our application, we will have to start 2 Docker containers, one with Postgres and one with our application. And it can be done with linking containers. So first, we run the same command, docker run. We specify a d flag to run it in background, and we give it a name, db. And then we specify an image name. So if we don't have this image locally, it gets pulled from Docker repository by default. And if you have it, it just uses your local version. And then we run our application linking our db to db. And this is all we need to change in our Rails application. Instead of using default host, localhost, we use host db. And we can just connect to Postgres. The other cool thing is volumes. Volumes are just shared directories. You can also share files, but you probably don't want to. And this is how you run volumes. You specify a path in the host computer, and you kind of link it, but you share it with Docker container path. And Docker repository is not really it's not strictly a Docker concept, but it's important part of the whole Docker ecosystem. You can think of Docker repositories as kind of GitHubs for Docker images. So you can just share your build images in the cloud. And you have several options here. You can use official Docker Hub, and it gives you free public repositories and private paid ones, just like GitHub. There are some alternatives. I haven't used them, but if you don't like Docker Hub, you can use them. And you can also run self-hosted Docker repository if you're, for example, concerned with security. And it's kind of fun exception to think of, because to run your self-hosted Docker repository, you must pull the image from another Docker repository to run it. So it's kind of cool to think of. And this is how Docker Hub looks like. Currently, it has 99 official repositories, including Nginx, Redis, Node, and Postgres. And these repositories are maintained by project creators, so not by Docker core team. And there are also a bunch of official, unofficial projects. And if you search for Postgres, you get over 2,000 images, which is madness. You probably don't want to use some forked Postgres image, but you can if you really want. So there's always a thing with trusting somebody who just pushed an image. Should I deploy it to production? OK, so we kind of know what Docker is. And how can we use it in development? And despite that, the fact that Docker has benefits in continuous integration and production, currently it's most widely used in development. And as I said, Docker shares kernel with its host operating system, and it's dependent on Linux. So what if I want to run it on my Mac, or what if somebody wants to run it on Windows? This is another part of Docker ecosystem created by Docker core team, which is very simple to set up. You just download VirtualBox, you install Docker machine, you run some command, and it gives you an interface on your host computer, and you can run Docker very easily with this. So it kind of works like magic. I wanted to show you some code, but it's just too simple. And in development, using volumes is really great. And this was my misconception for the first, when I first heard about Docker. I thought that you either have your whole application in Docker, or you always use volumes, or you always keep your code outside. But fortunately, you can have best of both worlds. And in your Docker file, you can copy your application to the directory, so your production always has the code there, so you don't need any external dependencies, or you don't have to pull the code from GitHub, etc. But in development, when you want code reloading and you want to use your favorite development environment, your favorite code editor, you can run it with volumes. So this was cool for me, and it was actually something that kept me away from Docker to the time I find out that it wasn't really the case. Docker Compose is another part of the ecosystem officially maintained by Docker team. And let's go back to our linking example. Imagine you get to work on Monday, and you want to start your project. So you would have to pull your Oh, I thought about pulling part. I forgot about pulling part. But you would pull your project from the repository. Maybe somebody changed something. You build it. You run database. And you run your project. OK. And imagine that we had to load, for example, environmental variables from another file. OK, it gets kind of more complex. And of course, we want to use volumes. And OK, if I had to do it every day, I would probably write a script for it. But OK, let's go further. And imagine that you have to also run Sidekick. So what would you do? You would start Postgres. You would have to start Redis, because Sidekick must use Redis. Then you run your project, but you don't start development environment. You don't start development server. You start Sidekick, and then you run your project. So it's not really convenient way to start your project. But instead of writing script, there is actually an interface for that, and it's called Docker Compose. You specify a YAML file, and you give a Docker container a name. You specify an image, and you just run it. This is how simple now it gets. You just Docker Compose build, Docker Compose app. You probably want to share this file in Git, for example, so your teammates always have the newest way to run your application. This is how it would look like with the Redis example. Okay, and so I dug into this Docker and I started thinking about some use cases. Where would it be useful? Where would it be pointless? So as I said, I work in Montreal and we are Ruby on Rails agency. And no developer in Montreal uses Windows. And I think only 2 of them use Linux for development. And all of them, and the rest uses Mac. And almost all of our projects are just Ruby on Rails project. So I don't really think that we're going to be Docker-based development company anytime soon, because there's, I don't think there's much gain in this to just get this for our all projects. But if you run microservices and you have to synchronize starting these microservices somehow, then this might be good use case for using Docker, especially if these microservices are written in different technologies. So when you have big teams, there's really no point for example, Java developer to have Ruby installed on their server because he won't write Ruby. And it's enough if he just can start the development. Another part that I could that I thought of is working with freelancers, and this is part of my another side project where we wrote some application and we are thinking about hiring some developer. And in our application, we allow users to upload STL files. These are files that specify 3D models. And we want to show them some information about these files, for example, volume and number of triangles, etc. And I found this great library. It's called AddMesh. It's written in C, and it provides command line interface, which was enough for my application. And I actually fall in love with this project when I get to the GitHub, and they give you benchmarks from 1996. I checked. It works kind of faster on my computer. And this is how you install it. So nothing really special, right? Unless you're on Windows, which is not to say that it's impossible, because I checked the changelog, and you can run it on Windows. But honestly, I don't care if it works on Windows or doesn't, because I will never use this application on Windows. And I certainly won't ever deploy it on Windows. So I can think of better ways to spend my time than to set up Windows development on my computer and check and write in README how to run it on Windows. And Docker fixes it for you. This is how you would install AddMesh in Docker. So you would keep AddMesh in your library, in your lib directory. You would copy it to your image. You would unzip it and configure make install. And now you have access to your AddMesh command. And oh, I think I got my slides wrong. Sorry. And it's gone. But fortunately, I think it's only one. So imagine you have some more, well, AddMesh might sound kind of exotic, but you might as well have, for example, image magic or whatever, which is pretty common. And you have this external dependency that you must install before you run an application. So this was Docker in development. And how will we work with Docker in continuous integration? And this is actually my favorite part, and I see big potential in Docker approach here. This is how the typical Rails continuous integration setup looks like. You copy your database YAML, you use RVM, you specify Ruby version, you run bundle install, you set up your database, and you run specs. And I had one problem with this RVM use. So you not only assume you have Ruby installed, but you assume that you have Ruby installed with RVM, and you have version 2.1.1 installed. So you have these 2 very separate environments, and you have to kind of keep them in sync. And I know that my application will probably work if I run it in development in Ruby 2.1 and CI has 2.2, but I don't really want to try it the hard way, right? And we also should have the same bundler version. And you might say this is like, it doesn't matter, that your bundler version doesn't matter, unless it does. Because I was working in a project that had 6 Ruby on Rails application, and we had a security issue with the way we were using bundler. And there was this update with bundler, so we had to update each of these 6 applications where had staging, pre-prod, and production environments, and we had our CIs. So, again, I can't think of better way to spend my day than to update bundler on all those servers. And, well, it doesn't really scale, right? So, this is my slide. So, you have your how would it work with Docker? And be really careful on this slide because this is some serious keynote magic here. You have your development environment, and you run your Docker, and everything is cool. You push your code to GitHub, and it triggers your continuous integration. And your continuous integration builds a production image. So not the same image we use in development. And how is it different? Well, first of all, we might want to install production gems, and we might want to precompile our assets. And when the specs pass on our CI, we push it to Docker repository. This is this magic. And we have this production build, which we can use then on staging, and we can use it on production. So, what are the gains we have here? Well, we have an image that has proven itself in this case. So there were no errors in the process, and our specs passed. They passed on an image that will be run in production. And this was our previous configuration. And this is how it would look like on CI. So this is just a setup. We assign a branch name to a variable, and we clear all the remaining Docker images, because we want to start with a clean slate. Then we run our Postgres, and we build our project. And then we set up our database and run our specs. So this is the point where we stopped before. Now, after our specs pass, we can tag our project with branch name, and we can push it to Docker repository. So what then? Let's see how we could deploy it in production. And I'm not an expert here, and I don't know if going the VPS route here is the best case, because there are some services, for example, offered by Amazon or Google, which run container as a service instead of virtual service as a service. So you might want to look at this. But I just wanted to try how to run Docker in production. Remember our Ansible example, when we had to install Postgres and Ruby, etc. And we still want to do some provisioning of our server, even though it don't require Ruby, for example. So this is how it would look like. We would still have some Linux prerequisites. We would install Nginx, which we don't have to. We can also use Nginx as another Docker container. I just wasn't really feeling that well with either Nginx or Docker in this case. So I decided to keep it the old way. And the most important thing our server needs to understand is Docker itself. And then we still have some site-specific roles. So for sure, we want to copy our envs, because even though we build our production image, we certainly don't want to have it your secret keys inside of it, because you will be pushing and pulling this image through different machines. So you shouldn't have your environmental variables there. And we have a prepare site, which actually can't create our database right now, and it can't copy our database YAML, because there is no Postgres, and this is in Docker image. So we just copy our Nginx config here. What is different and what stays the same? Well, we still have to configure Nginx. Instead of touching GitHub, we pull image from Docker repository, and we have to synchronize starting containers. Instead of synchronizing our processes, etc., we have to look after our containers. And we still need some kind of monitoring. So if our application dies, we want something to keep it up. And this is an important pattern when you want to run your Postgres as a Docker container, because you want to decouple your Postgres or database engine from your database data. So you could use volumes, but still it's kind of you have this requirement that you need to have some directory on your system, and you don't really know what maybe are permissions on this directory, etc. So it's better to use it as a Docker container. And we do it this way. So we specify our Docker run, we give it a DB data name, we run Postgres, but it doesn't have to be Postgres. We do it just because we are sure that we have Postgres image on our computer. And we run echo data-only container for Postgres. And after the echo, this Docker container just exits, because there's no process running in it, so it exits. And we don't want to keep it up, because it won't do anything. So it would be just wasting our resources. And then we run Postgres, and we specify that all our volumes, which are specified in Postgres as a Docker file, are coming from DB data, so not from our host computer. And when I thought about synchronizing our containers, I thought that, well, we might use Docker Compose. It turns out that we shouldn't. So all the sources I was reading on the topic told that Docker Compose is best left on your development. So no Docker Compose. So we can just rewrite a script. And we're running our data-only container, or we echo that it's already started, so it won't exit with a non-zero code. And then we run our Postgres. Oh, and look at the restart always option here. So this is Docker taking responsibility for keeping Postgres always running. And I still don't know if it's the best pattern for Docker to do it. And maybe it is better to give it to some external tool. But this is an option you have. And then you pull your project, you tag it with your master branch or whatever branch you're pulling. You're tagging this image with how you want to use it. So you might not care what branch you pulled from this point on. And then you run your migrations, you run your you're killing your server here. So I still don't know how to do deployment without stopping containers, just like I didn't deploying my application without stopping my server. So this is certainly a point where we might improve right now. And then we run our project. And again, with restart always. So this is you can just write in the script and have the script to deploy your application with Docker. We could also use Ansible. It has some built-in command for working with Docker. It looks like this. So we specify your name, image, etc. Almost all the things you can just do with Docker. I saw some blog posts where somebody wrote a Capistrano deploy script. I won't show it here because it's generally all the same things. And you can also use, and as I said, for monitoring and keeping your system up, you could also use some external tool, for example, Upstart or systemd, etc. And, well, is it worth it? I don't know. You have to answer this question for yourself. It was a cool journey for me, but I don't know if I will be using Docker in production for all my Rails applications. Probably not for all my Rails applications, because there might not be really that much gain if you have only one application and you work mostly with one technology. But from what I heard on conferences and read on blogs, when you have multiple projects and you have projects with microservices, then Docker might be really, really great gain with deploying it and with scaling it. Thank you. Do you have any questions? OK, I think not. So thank you.